Okay? So likewise, what is happening? All the conversation is happening and this girl is getting, yes, the machine is understanding me. But there was absolutely no understanding. Absolutely no, because you can figure out. It is happening based on some kind of pattern and independent responses. It's not that this response is dependent on the previous response or some context has been taken. No. So likewise, this test passed the Turing test, but later on it was realized this is just a dumb test. Only some strings have been taken out and some responses have been formulated. So now definitely we need to have some more intelligence, understanding part to be inculcated in the program rather than doing some kind of thing which looks like human behavior. So again, they are called intelligent systems because you are conversing. And similarly, for example, we have expert system. So expert system, what it does? It will ask you questions, will try to extract few information. There is some rules available and some database. From there it will try to infer some. So that is little more intelligent than this kind of dumb program. Okay? So it was just an initial one. So foundations of AI, basically they are based. We have mathematics there, neuroscience, control theory and linguistics. And in every field, everywhere intelligence is required. We can say in game playing, in understanding, comprehending. So all those things will require intelligence. And for that we need to have mathematics as a basis, develop some tools, neuroscience, control theory, and like this. So mathematics basically will have these kind of logical methods over which we can make our AI systems. So Boolean logic, fuzzy logic. Boolean logic already we know in schools, binary one. Fuzzy is basically, normally in real life we are always dealing with fuzzy systems. He is beautiful, she is tall. So those kind of things, not concretely 0 or 1. So fuzzy logic also is a mathematical model available. Uncertainty, that means how to handle uncertainty in AI applications. Because sometimes what happens, knowledge is not precise, not exact. So a lot of uncertainty is there. Probability, and sometimes we call like this. So for that we need to have, so probability is one theory which comes for SQ, and then modal and temporal logics also, they can handle some kind of uncertainty. Neuroscience basically is an area, cognitive, where how brain works and what is to be done. Control theory basically machines that can modify their behavior in response to environment. And this also happens that we as a human also change our response depending upon what situations are coming. So in machines also we see whatever the environment is, sense and action loop. If pressure is increasing, it will decrease temperature and stuff like that. So those are those theories. Linguistics basically handles natural language processing and understanding speech and those kind of stuff. And I was really surprised to see that when way back in 90, I wanted to have some intelligence system to understand a paragraph, English paragraph. So a lot of challenges were there because first system will not understand what you are writing. So for that you need to have the grammar, then semantic, and then you have to extract the knowledge what is being, or maybe meaning of the sentence, and then try to give you response. Because comprehension when it comes in English, we read this paragraph and some questions are there, and based on whatever we extracted from this paragraph, we answers. So that kind of model I wanted to make, and you will be surprised to see that it took a lot of time in building this knowledge, and this knowledge is in abundance with us. We can easily comprehend. So the computers doing such kind of thing is really challenging. So analysis of human language reveals thought that taking place in a way not understood in other settings. For example, children can create sentences they have never heard before. How they can create? So they learn in the process of growing up, isn't it? Languages and thoughts are believed to be tightly intertwined. So those kind of learning the child is going through, one has to build models also in that area. So there are two views of AI goals. One is AI is about duplicating what the human brain does. One view, which basically is the area of cognitive science. Another is AI is about duplicating what the human brain should be doing. That is, your things doing logically or rationally. These are the two major AI goals. So now this is the cool stuff where you all require intelligence. So build any application, and then you have to gameplay, machine learning, speech, language, vision, data mining, web widgets. All these are your basically AI related applications, and then try to build some models which can do these kind of things. For example, in game playing, chess game has been made. Now what kind of intelligence might have gone there? When the two humans are playing chess, a person sees the move of an opponent and tries to calculate at least 4 level or 3 level, whatever his wisdom is, that if I'm playing this, he might play this. If I'm playing, so now just see, human mind is not that big that entire all possibilities it can consider. Here computers are more capable, because we can just scan. If these are the possibilities, if I'm going through, he is going to have these possibilities. Then if I choose like this, likewise you can build a complete tree structure, and whichever is the winning path, all possible plays of that game one can always store in the computer, and whichever is the winning path, you can always play accordingly. So now it will look like this thinking, but again there is no thinking, but yes, we have put all the information which is required, which we cannot capture in our mind, and then just have that path. So vision, basically we see, then try to interpret those scenes. Language is natural language, speech and all. Machine learning, basically that the way we learn, machine should also be made capable of learning. For that will mean that we need to have, for example, neural network is one learning paradigm. That we have got evolutionary computation, as per nowadays it has come up, where how human race has got learning. This is called genetic algorithms. Then ant colony, that how ants are intelligent enough to go to the food, and likewise. So evolutionary computation is another way of which helps you in modeling the learning. Data mining, again, that lot of information is available, you extract some important information out of it, mine that data and get the information out of it, which is hidden, but information is there. Similarly, web agents are there who are doing job on behalf of you. They should be intelligent enough to see what is your requirement and try to move around in the web. Useful stuff could be something like this, which are really useful. Those are the things which are definitely requires intelligence and keep on doing things there. But here the important stuff could be medical diagnosis, okay, fraud detections, which are really useful to have our comfortable life, object identification, space scheduling, information retrieval. All these are very important components where we require AI. So majorly AI techniques are rule-based techniques. We can write programs rule-based. Fuzzy logic will come to rescue for handling uncertainty. Neural networks and genetic algorithms. So now, what are the major components of AI and how this AI program is different from ordinary program? We are writing so many programs. Add this thing, do this, find maximum, minimum, sort this. So all these are the programs. Now, how these programs are different from AI programs? So AI program basically should be learning in nature, and it should be able to update its knowledge accordingly. Knowledge base, what is knowledge? Data, knowledge, all these terms we are hearing. Information, data, knowledge. Data is just a unit, some information. Information is processed data. And knowledge basically consists of facts which are there and the rules put together. And this is one set of knowledge. For example, as I mentioned that in expert system also, there will be some basic facts available, some rules will be available, and then when I'm using the system, As an individual user, it will have its own knowledge to be fed into the system. And with this system, this knowledge, with this one, you will get the diagnosis according to your symptoms. So that's how this expert system is very classical example of AI program, where you can get the advice that probably with these symptoms you will be having this kind of diseases. Okay, so a knowledge base consists of facts and rules, and first we have to understand characteristics of knowledge. Definitely knowledge is voluminous and it requires proper structuring. Within the brain also I do not know, or we do not know how the knowledge has been structured. Sometimes when I am trying to retrieve something, it immediately comes. Sometimes you just fire a query and maybe after half an hour, oh, this is the response of that query. Have you noticed that? It's happening. How it is inside stored, there is subconscious and unconscious. So subconscious level has got the immediate memory, short-term memory. And then things which go permanently, they go on to unconscious level. So that's how. And unless we know this entire structure, we will not be able to store this knowledge. But yes, whatever is available, people are trying to store them. So characteristics knowledge, voluminous, is complete, incomplete and imprecise, and it keeps on changing also. It keeps on changing. Sometimes I have this belief system, for example, whatever. Later on maybe it will go. I have another belief system. Or this knowledge was not correct, so I have deleted. I will not be using that. So this is dynamic and keep on changing. So this is one component, that we have a knowledge base in AI program. This is my big AI system. It has got a knowledge base. Then it has got